Six-sided dice is rolled twice. What is the probability that the first number that comes up is greater than or equal to the second number? So first we have a six-sided dice and it's rolled twice. So we can have two columns where this is the first roll and this is the second roll. So in the first roll column we have the six-sided dice, so we have the numbers 1, 2, 3, 4, 5, and 6. And in the second column we have the numbers 1, 2, 3, 4, 5, and 6. So it's asking for the probability that the first number is greater than or equal to the second number. So first number we have is 1, which can be paired up with the 1 in the second row column. So we have the number 1 only has one possible combination. So it's only equal to the number 1 and it's less than all the other combinations. So if we have the number 2, it's greater than the number 1 in the second column and it's equal to the number 2. So the number 2, we have two possible combinations. The number 3, it's greater than 1, it's greater than 2, it's equal to 3, so we have 3 combinations. Number 4, greater than 1, greater than 2, greater than 3, equal to 4, 4 combinations. And if we go all the way to the number 6, from 5 we have 5 possible. And then number 6, we have 6 possible. Since it's greater than 1, the numbers 1 through 5 and equal to the number 6. And then we have 1 possible, 2 possible, 3, 4, 5, and 6. So if we sum up these numbers, we can use the sum of the n numbers formula, which is n times n plus 1 over 2. And for those of you who don't know how we got this formula, I can give you a proof here. So if we have one square and another square that's stacked up and another square that is stacked up, so we have 1, 2, and 3 squares. And then if we suppose that we slice this in half, so we have a cube. And we suppose that we slice this in half, and we take the other part and we flip it on top of this figure. Then we have this 3 cubes, then it comes up on this side, so we can write it in, draw it in a different color. So we have these 3 cubes can be sliced in half and then flipped over and matched over here. So we have these 3 cubes. And then since we had these 3 cubes, the next cubes are these cubes, which can be flipped over also. And then if we flip those cubes over, we have first cube, second cube. And then lastly, we have this single cube right here, which is also flipped over. So if we flip it over, we have the cube right here on top. And then this cube was this row. So if we redraw this cube, since it's easier to see, this is this row right here. And then since we had the first cube, second cube, and third cube here, we had the numbers 1, 2, 3, and we sliced it in half and we put it on top. So this was the original 3 at the height, as the height, and then we added an additional row of cubes since we flipped it on top. So if we suppose that we have the n number of cubes, we can write n times n plus 1, since we added another row by flipping it over, and then we divide it in half since we've sliced it in half and then flipped it over. So that's how we got the formula. And then we'll delete this to get more space. And then since we know how we got this formula, we can use it in this scenario. So we have n as the 6 possible, so we take the 6 and substitute it as n. 6 times 6 plus 1 over 2. So that's 6 times 7 over 2. 42 over 2 equals 21. So the sum of these equals 21. So we have a total of 21 possible combinations. And then for the total number of combinations, we had a fair 6-sided dice is rolled twice. So we have 6 possible combinations for the first roll, times 6 possible combinations for the second roll. So we have a total of 36 combinations. And now we had 21 successful, so it's 21 over 36, which can be simplified to 7 over 12. So D is our answer.